So in this section, we will talk about the various algorithms which are used in the kind of machine learning and how these algorithms are important and different to each other. So let's move ahead. Section 4.4.1 describe how data and algorithms are related to each other. So you can definitely think of getting at least a question, not if not more than one, from this slide. So this basically this talks about how the data and algorithms are different to each other. So this slide basically focuses on the importance of algorithm and how data and algorithm are related to each other. So in the case of machine learning algorithm, it is nothing without data. So if there is no data which is there to be fed to the machine learning algorithm might not be able to work. The algorithms, as we say, are the sequence of steps that takes the input data, responds to the hidden pattern in the data, and algorithm basically react to the data as it changes continuously, like we react to the kind of weather or environment conditions where we live in. So your machine learning algorithms are tuned. They are the step of they are the flow of steps which basically tune itself based on the data which is fed across to the algorithm. So we basically use a set of weighted parameters which we call the hyperparameters, that basically control the learning process of algorithm. So by selecting the appropriate and influencing variables, kind of weightage, the kind of algorithm can perform better in terms of identifying the pattern and reporting them into the decision makers basket. So the focus is how the algorithm and data are closely related to each other in the case of data analytics project. So as we say, algorithm is a sequence of steps which helps you to react to the data, and as the data changes, your algorithm basically tunes itself to the changing pattern in data. Algorithm, as we see, definitely learns from the data. It learns from the kind of pattern which is identified in the data, and based on the kind of pattern which is identified, it try to give you the prediction for the future set of data. So as we said, uh, your computers have a perfect memory. They can respond to massive intake of data through the likes of algorithm. Why they are able to respond back? Because there are pre-fed algorithms for these computer, and then they try to apply back based on the data. Section 4.4.2 clarify how regression analysis can be used to describe patterns in the data. So in this section, we will first understand what is regression analysis and then how regression analysis can basically help you to describe the overall pattern in data analysis. So regression analysis, as we understand, is more of a technique of statistics wherein you will try to model one or more independent variable and a dependent variable. So it is one of the most simplest model in statistics then that can be applied in data analytics for prediction. So this is one of the earliest and most simplistic model. So the technique relates your input variable, which is your independent variable, to the output variable, which is your dependent variable. So your input variable is always your independent variable, and your output variable is your dependent variable. So it is all about how accurately your dependent variable changes with regards to your input variable, which is your independent variable. So let's consider by an example. So let's consider by an example of data set where we have collected large number of heights and weights of the sample population. So let's assume that in a city we have uh, collected lots of values of heights and lots of values of weight. So when we draw a plot of height versus weight, we will see almost a linear relationship between them. So which means that as the height increases, your weight seems to increase as well. So what does it mean? That a height is an independent variable and weight is a dependent variable. So when you say weight is a dependent variable, that is depicted on a y-axis, and height is a independent variable, hence it is depicted on a x variable. So if you see it over here in this plot, height is an independent variable, it is depicted on a x-axis. Weight is a dependent variable, it is depicted on a y-axis. So based on this, when we draw a plot of height versus weight, we see almost a linear relationship between them. So as we say, the height increases. As the height increases, the weight will also increase. But to get the best relationship, we must come up with a line that basically passes through most of the points on the chart. So if we have to predict, if we have to generalize the prediction, we have to find this line which should pass through all these points. So if you see these points, these are the pointers of population where for x height there is a y weight. So we have to find this line which should be basically depicting the overall generic population. So as the height increases, the weight seems to increase, but to find the best relationship, we should come up with this straight line that passes through all the points on the chart. So this line as we call is called a hyperplane. Then basically best represent the true nature of relationship between the height and weight of a person. So the line is called the hyperplane, and through this line you can basically depict the true nature and relationship between the weight and height variable. The more data we collect, the more accurately we can establish the relationship between height and weight variable. So the real value of regression technique is its the ability to predict. So what it says, once we get the equation, say y is equal to weight, y equals to say a plus x, where a is a constant and x is your height. So if we get that value of a and x and y, we will be able to predict the values of weight and based on the input which is given across. So hence, the more data we collect, the more accurately we can establish this relationship between height and weight. The real value of regression technique is its ability to predict, as we call it. And in this example, given a height, we should be able to predict the weight based on the relationship which we have established. So if we know the height, we should be able to predict the weight of a child. If we have clearly got this straight line on the slope of the straight line. So there's an important concept of slope when it comes to the linear regression. So whenever we are talking about the linear regression, the slope for this is a straight line. So slope is essentially a change in a dependent variable over the change in a independent variable. So if you find the slope is basically your delta y upon delta x, which is the change in a weight variable with regards to the change in your height variable. So that's the overall slope.